Welcome back to geometry. Today we're talking surface area. This is 11.2, and really at the most basic level it's easier than volume. Maybe cylinders, you have to think a little bit more, but the basic idea of surface area is it's the sum of all the areas on a figure. The sum of all the areas. So if you can identify what all the areas are, you just add up those areas. Most of the time the areas will be triangles or rectangles, or circles. Really, that will cover everything today. One of the things, the cylinder we'll do last. The area around the cylinder, often called the lateral area, is one we have to talk through a little bit. But otherwise, you're adding up the areas of all the faces. So it might take a little bit of visualizing, like on this first example here. This is a triangular prism. Can you tell how many faces it has? Has 5 faces. I could try to count them, but well, let's do this. Here are the faces. Let me try to draw like this. So there's a front face that looks like that, and a back face that looks like that. There is a left face, that's a rectangle. A right face, it's also a rectangle. And a bottom face, which is also a rectangle. Something like that. Those are the 5 faces. I'll just try to label them here. So let's call this 1, 2, 3, 4, and 5. And 1, that front triangle. 2, the back triangle. 3, the left. 4 is this here. See, it's getting all jumbled now. 5 is the bottom face down there. Okay, I don't think that's really good to have on there long term, so I'm going to get rid of all that. That's what we're going to add up. So let's see here. Okay, so we have the front and back are the same. Do you see that? So I can just do 2 times whatever the front is, let's say. So we'll say the front is a triangle, so it's 1/2 base times height, right? That's that first part. That was this right here. The front and back are both 1/2 times the base times the height. Okay, I'm going to back out of that again. We need to add that to the, we'll say, next we'll do left face, which is this one right here. And the left face is just base times height, which, since that is 2, that's also 2. So it'd be 2 times 4. It's kind of like subtract. Let's do that. By the way, this one is 12. This one is 8. So the 12 is the front and the back. Each one is 6. Let's do the bottom one next. We'll do that one next. Oh, let's back up. No, I don't want to do that. Okay, sorry. I'm trying to be fancy here, and this is backfiring on me. Okay, let me just recalculate that again. 2, that's 2, that's 2, that's 4, that's 3. 2 times 4 is 8, and this I already said was 12. Okay, the bottom one next. The bottom one, now I've labeled it all. You can tell is, see that one? It's 2 times 3, the bottom. I'm going to go back now and get rid of that. Okay, so 2 times 3, that's 6. And then the right face, the slanted one. Let's try to label that one right there. That the right slanted one, see that? So one dimension, just I'm gonna back that off again too. One dimension, let's just draw it over here. One dimension is this, 2. And what is this dimension here? It's the same thing as that. Well, it's not labeled. It's not 3, it's not 4. In fact, it's the hypotenuse of a right triangle. It's 5. It's a 3, 4, 5 triangle. You can check that Pythagorean theorem if you want. So that one you had to think a little bit about the Pythagorean theorem or triples. So we get 10. We're going to add all of these up. What do we get? We get 20, 26, 36. 36 square inches is the surface area of this. So you just add up the faces. Try to count them maybe in the beginning and make sure you account for all of them in the end. So on this one I had 1, 2, 3, 4, 5 faces. I accounted for all 5 of them. Okay, let's try another one. Probably the easiest, rectangular prism. I probably should take a little more time and draw these nicely. Let's see if I can get rid of that line. Got rid of more than I wanted, but try to make it a little nicer. Okay, we'll put some labels on here. Say this is 3 centimeters, 2 centimeters, and 7 centimeters. So how many faces does this have? Well, it's got a top and a bottom. Top slash bottom, that's 2. It's got a front and back, that's 2. And it's got a left, right, that's 2. So 6 faces. You know, a cube is a rectangular prism. A die, or plural form dice, singular form die. A die has 6 sides because it has 6 unique numbers, 6 sides, right? Look at a box. Find a box in your room, or even a textbook. The top, the bottom, the front, the back, the left, and the right. Kleenex box, something like that. So there are 6 sides to that. So the top and the bottom. On the top and the bottom, let's see. Well, let's look at the bottom there. That is 3 times 2. And there's 2 of those, so I'll multiply it by 2 because there's a top and a bottom, right? I'm just going to leave those lines there this time. The front and the back. Well, we know this is 7. This is 7. That is 7. So the front and the back is 7 by 3. And there's 2 of those, a front and a back. The left and the right is 2 times 7, or 7 times 2. And there's 2 of those, a left and a right. So you get to multiply these out, it becomes 12, 42, and 28. That has to be 70, 82, right? 82 square centimeters. So for surface area, we are dealing with square units. One interesting thing about this problem, with the rectangular prism, you don't have to really visualize it. Here's a little trick. Every number, look at the unique units, 7, 3, and 2. Every number gets to be used twice, right? The 3 used there and there. The 7 used there and there. The 2 used there and there. Every multiplication is different. It's kind of like 3 people meet in the hallway and they all shake hands. Then there are 3 handshakes. So there's the 3 and the 2 shaking hands, the 7 and the 3 shaking hands, and the 7 and the 2 shaking hands. So really, if someone just told you, hey, the dimensions of a rectangular prism are 5, 7, and 12, you just know it's going to be 5 and 7, 2 of those, 5 and 12, 2 of those, 7 and 12, 2 of those. You don't even have to look at the sketch. But when in doubt, just add them all up. Let's do cylinders next. This is the one that may be daunting at first glance. Okay, so that wasn't my best cylinder, but we'll go with it. Let's say this is 8 feet. That's the diameter. And this is 10 feet. That is the height. What is the surface area of this? Well, let's figure out how many faces this has. Imagine a can of soup. And you drop it, okay? It could either land right side up, It could land upside down. Those are pretty unlikely. Or it could land on its side, and in that case, it's probably going to go rolling away, which is the most likely scenario. So there's three faces. Three faces. The easiest ones to note is the base, the bottom, and the top. They're both circles, and it didn't draw it very well. They are congruent to one another. So this has two circular bases, right? The top slash bottom. So what is the area of that? Well, we know the radius. Whoops, didn't mean to do that. We know the radius of this thing is 4. Right? So when you're doing, so surface area will be the two circular bases. I'm not going to write surface area yet, sorry. So you have your two circular bases. So those are pi 4 squared, right? The area of a circle, don't forget, is pi r squared. Still need to know that. Circle. But we have 2 of those, so times 2. And then the trickiest part, maybe, we have the distance, not distance, the area around. Textbooks call this the lateral surface area. And I remember when I first learned this, I thought, this is daunting. How are we going to know? It's curved. What are we going to do? But then I remembered toilet paper. I remembered paper towels. I remembered soup cans. When you tear the label off a soup can, let's just do it right here. And you lay it out there, it looks kind of like this. I made it really jagged, didn't I? Or toilet paper. It's in a cylinder, but you tear it off, look at it next time, it's a square. Paper towel, you tear off a piece, it's a square. Not a well, or a rectangle, probably more likely a rectangle. So let's think about that rectangle. What is the height? I just gave it away. It's the height. What is this dimension? It is the height of the cylinder. So to get the area of a rectangle, all we need is the two dimensions. We got one. That wasn't so bad. What is they're like, oh, this is the hard one, right? This one, how are we going to get this? We got to figure out, really, it goes from here all the way to there. Hopefully this is not too busy for you. Let me draw that again. Let's draw a quick one here. So if you tear this here and you unravel it, that distance is that elusive length. What is that distance? That's the distance around the circle. Wait a second, that's circumference, right? And circumference, we know, is 2 pi r, or pi d. So, I'm going to summarize all this in a moment, but so we have this lateral surface area is 2 pi r times h. We don't have to multiply by 2 this time. There's only one of them. But we have that, and we have that. And you add them together. So in our problem, I guess it would be, so the surface area, let me summarize this here. Surface area is the 2 times the area of a circle plus circumference times height. I writing this out just seems weird. No one memorizes it that way. Let me just redo that. Let's say area around. Okay, that's my description of just the area of the label or whatever going around the cylinder. So how do we do that? That becomes 2 pi r squared plus 2 pi r h. And if someone asks me that on the street, I don't know this formula. I don't know it. I just figured out, I think, well, 2 circles, area around, that's 2 of those pi r squared things, and 2 pi r times 8. So I can figure it out pretty much immediately, but I don't memorize it abstractly. So in this problem, it'd be 2 pi times, what do we say the radius was 4? 4 squared plus 2 pi, 4 times the height was given as 10. So this is 1632 pi, 80 pi, which is 112 pi units feet, square feet. Okay, that is surface area of cylinder. So let's summarize these. Surface area of cylinder. Did I write that down? Here we go. You might like either one of those. Can use red. Either one of those. Surface area of a rectangle. I didn't write a formula. We don't need a formula. And same for triangular prism, I guess, because they're just the adding up the areas around the object. I know we're probably going pretty long here, but I was going to do 2 videos. Let's just do it all in one. Let's just wrap this thing up. I got one more left to do with you guys. And this is in the textbook on page 706. It is number 41. So far you might be thinking, this is easy, I got this. This one ups the ante a bit. So hang with me on this one. And this is a real challenge to draw. But I'm gonna do my best. So you might fast forward me here to get to the end of this. Should be straight down. How does that look? So this goes out here. Whoops. Like that. Like that. Oh, just trust them. That's how they do it. Okay. I think I could do better than that. I don't know. That probably is better the other way. Okay. So here's the shape. That took up like 5 minutes. I probably should have paused the video for that. 3 inches, 10 inches, and this is 8 inches. I'm going to find the surface area of this. So the key, I would say, is adding up all the surfaces. So what surfaces do we have? How many do we have? Well, we have a front and a back. Those are the easiest, right? Front slash back, 2 of these things. And these are simply 3 times 10, and there is 2 of them. So that's 60 square inches. Not so bad. Okay, the other one's gonna be a little trickier. Let's do top and bottom next. Top and bottom look like it's gonna draw it 2-dimensional. Whoops. Not the greatest looking, but that's really bad. Gotta do that again. Try one more time. Because it should be part of a circle. Okay, we'll go with that. So this is 10. Whoops. This is 10. And we know this is 8. The 3 doesn't matter here. That is like the center of the circle. So the radius of the circle is 4 inches. Okay, so what is that? What is this shape here? Hopefully you're realizing it's a semicircle. Well, look over here. This shape, that's 4 inches also. This is a semicircle. So what do we have? We have a rectangle, right? If I draw around this, that is a rectangle with 2 semicircles cut out. So, and this, by the way, is the top and bottom. Top, bottom. So the area of, there's 2 of them, but the area of it is the area of the rectangle minus the area of the circle. I could say 2 times the area of the half circle, but those 2 yellow parts make up a full circle. So it's simply the rectangle, which is 8 times 10, minus the circle, which is pi 4 squared times 2. Done. Yes, that's right. Make sure I wasn't wrong there. Okay, I think that's right. And then finally, the sides. Ooh, what are those things? Let's just shade them on here because I can't. You don't want me to try to draw this again. That and that. Well, first you see that those are the same, right? Then those are really the left and the right. Left, right. They are the same. And if you can imagine, what if you were to break this in half, like that, and put these together? What would it look like? Like turn them so that the curved parts are together. It would look like this, wouldn't it? Look like that, wouldn't it? It would go up to the top. It looked like a big circle. So really, this is a hard one. That's why I picked this one. Yours is gonna be easier than this one. That's why the yellow part makes up the lateral area of a cylinder. If you can imagine that. Like if you would put those together like that, this would be like a cup holder, right? This part is solid, and the circle inside is a hole, like a little cup holder. So I want to find the area of the side of the cup holder, basically. So essentially, it's a cylinder. Hey, it's a cylinder. So let's draw that cylinder. There's a little cup holder. So now we're looking at more 3D image. And you could do the inside layer of the cup holder, but you know what? The outside would be the same. It's just 2 sides of the same like piece of paper. So this is the height, which is 3 inches. That's the height of the cup holder thing. And the 10 doesn't come into play here. The only other thing we need to know is this is 8 inches. And since those 2 yellow parts make up a whole cylinder, we're just going to do the lateral surface area of one thing. So essentially, if we were to take this and tear that off, what's the area of that label? So this again is 4, the radius. So the lateral surface area, if you were to tear that off, it looks like this. This is 3, and this dimension here is 2 pi times 4. Or I could have just said pi d, pi times 8. So there's only one of these. So this area is just going to be 3 times 2 pi times 4. So, okay, let's add those up. Let's add up. We already got that at 60. That, and that. Okay. So, sure I got this right. 3 times 10 times 2. So we have the surface area. Let's go to black. Is 3 times 10 times 2 plus, I'm going to put 2 in the front. 2, 8 times 10 minus pi 4 squared. And then finally plus 3 times 2 pi times 4. So as you've heard me say, it's always nice to show the initial setup so people know where things are coming from. You might even label above here, you know, this is the front and the back, front, back. This is the, what was that again? Top, bottom, top, bottom, and this is like the sides. Front, back, okay. So this becomes 60. This becomes 2 times 80 minus 16 pi. And this becomes plus 824 pi. A little bit of simplifying. 60 plus 160 minus 32 pi plus 24 pi. Or final answer, 220 minus 8 pi. So we could combine like terms here. Those are constants. No, they're all constants, but these have no pi's. These have pi's. And I didn't actually. Yes, I got it right. That'd been scary if I got it wrong. So that is my area in square inches of this shape. That is a tough one, but the main thing are the first 3. Make sure you can do the first 3. There's one on the homework like this last one, but it's not as nearly as bad as this one. So